Hello, this video addresses the ways to set up layouts of different control objects on a form in Windows form programming. Here's the outline of the lecture. First, I'm going to focus on fixed layout and talk about location, size, and different modes of snapping objects on a form like a SnapToGrid and SnapLines. Also, I'll talk about padding and margins, Z order and tab order. After these properties of fixed layout, I'll focus on dynamic layout, including how to do anchoring, docking, how to basically create a tool strip container and use it to create a nice dynamic layout for objects on a given form. And also I'll talk about how to use a split container and a splitter to create a dynamic layout of objects on a form. And then finally I'll talk about table layout panel, which is going to be very useful in different applications. Let's begin talking about fixed layout by going over position and size, or sometimes just a position, we say location. Position basically specifies where your object is. For example, if you're setting the position or location of this control object, which is a button, at 31 and 35, it basically means the bottom left corner of this control object is 31 pixels away from the vertical left border of the form, and it's 35 pixels away from the top horizontal border of this form. So 35 pixels and 31 pixels. That makes the location of the control objects equal to 31 and 35. So basically, the location is specified by an X and a Y, which we call it an object of system.drawing.point. Size, on the other hand, is captured by the size property, which is a type of system.drawing.size, and it specifies both the width and height of the control object. So for example, this control object that you see has a width of, let's say, 40 pixels and a height of 20 pixels. So we say the size of this control object, this button, is 40 and 20. Please note that if you're using Windows Form application project in Visual Studio 2022, you can simply change both the location and size of an object using mouse. You can just drag and move this control object around to change the location, or you can basically grab this border line of the control object and change the size very easily just using the mouse and by mouse movements. You don't need to write the code yourself, or you don't even need to go to the properties and change the location property or size property of an object. You can just use a mouse to do all the changes that you want. One of the challenges that you face whenever you're setting the fixed layout of your forms and basically making sure that your form contains the objects in the nice looking fashion is that how to take care of the alignment and how to nicely align different objects with respect to each other. Windows Form Designer in Visual Studio can help you do that by providing you two different layout modes. One is called the SnapToGrid, one is called SnapLines. The SnapToGrid mode supports snapping to a predefined grid, As you see in this shape, I have this grid, and I can basically place my objects in any of these points that I'm basically highlighting and annotating. You cannot place the objects in different locations. All you need to do is to select one of these predefined locations on the grid and place your objects there. Now, can you set up the dimension of your grid? Yes, you can set the dimensions of your grid, which means the number of rows and columns, in the same location that you configure the layout mode, which is going to be Tools, Options, Windows Form Designer, and General. That's basically the place that you can go in Visual Studio to change the layout mode to a SnapToGrid, and also to change the dimension of the grid. If you need more freedom to place the objects on a form in locations different than the locations specified by the grid that I showed you earlier, you can use SnapLines static layout mode. This mode allows you to align your control objects better and with more freedom. When controls are dragged onto or around a form, or when the controls are being resized actively, you will see some snap lines that are manifested as one or more sticky lines, which guides you to the nice alignment and allows you to place your control objects in a way that they are aligned with each other. Basically, you can see these lines. There is a control edge alignment snap line, which you can see here, this vertical line, or you can have text margin alignment snap line, as you see these lines that shows the distance, the vertical distance between the label here and the text box. And also, let's say, the text baseline alignment snap line. For example, the baseline of my label and my text box texts are being aligned together, and also it allows you to align your control objects in a way that the space proximities are preserved. In this case, my label and my text box are getting too close to each other, and in this situation, you will see the space proximity snap line, which shows you the horizontal distance between these two, and it allows you to place the text box close to the label, but not too close that it violates the margin of the label. So that's a very useful feature that you can use when you're setting the location or size of your control objects. Another property that allows you to customize the fixed layout of objects on a form is padding. Padding is the internal distance in pixels from the edge of a form or controls client area that child controls like text, like images, so on and so forth, cannot intrude on. What does that mean? Basically, you cannot get closer than some minimum threshold to the border of a container when you're placing objects inside it. That's a little bit easier definition in layman terms. And you can either configure it by typing some code, or you can basically go to the Visual Studio design area and change it in the properties list. Please note that padding is implemented on the base control class and most controls that derive from them, like most of the controls, user controls that we are dealing with, or container controls or forms, and some controls like text box, list view, or month calendar, they don't support padding. Why? Because either the padding is fixed or it doesn't make sense for them to have padding, right? For example, for the month calendar, the padding is already fixed. You're not allowed to change it. And if you are allowed to change the padding, you can either change it in the code, or you can change it using the visual designer of Visual Studio. The default value of padding would be 0, but as I said, you can change it if you want to any value you want. Here are two ways to customize padding and change the value of padding. One is in the properties window in Visual Studio. You can either change all of the padding values, the left, top, right, and bottom to the same number, let's say 3, or if you want to change padding in different directions individually, you can just change any of these values you want. For example, you want to have more padding on the top than the bottom, so you set, for example, this value top to, let's say, 6, and bottom can be 2, right? It's completely customizable. Another way of doing this is to basically go to the code and change the code by saying, for example, this the padding label, the padding is equal to whatever you want to set the padding equal to. Another property that allows you to customize the static layout of your program is margin. And margin defines the spacing between adjacent controls, and basically it makes it easier to adjust the distances between different objects on a form. You can configure the margin either using controls margin property in the bottom right corner of a Windows form when you see the properties window, or you can just go to the code and change the margin property by typing the values in the code. And please note that every control that you can find in the toolbox has the margin property and implements the margin property, except for form. The form itself doesn't have margin because margin is useful only within a form's client area. When you set both the margin and padding of different objects in a form, you can calculate the minimum distance between them. For example, in this shape, assuming the button has a margin 10 and padding 10 on all sides, and this button has the margin of 20 and padding of 0, and let's say this form has a margin of 0. Actually, you cannot say it's margin because the margin is not defined, but the padding is 10. Then I will say the distance between the form, the minimum distance between the form and this button would be 10 plus 10, which is 20. The distance between this button and this button would be 10 plus 20. So I'm just adding their margin, the right margin of this button and the left margin of this button. So 10 plus 20, which is equal to 30. The distance between this button and the right-hand side border of the form would be 20 plus 10. So the padding of form on the right side plus the margin of the button on the right side. I'm sorry, the padding of the form on the right side plus the margin of the button on the right side. I was correct at the beginning. So, which is going to be equal to 10 plus 20, which is 30. And as you see, this button has 0 padding, but this button has padding equal to 10. That's why you see this gray border on the button that doesn't let any text to enter this gray area, but this button has absolutely no interior gray border because the padding is equal to 0. Another property related to static layout of an object is called z-order. All controls in the same container, let's say in the same form, are logically ordered in a vertical stack, which controls a higher in the stack being rendered on top of the controls lower in the stack. So the higher you are, the later you're rendered on the containing control. The position of a control within the stack is defined by z-order, and it's implicitly determined by the order in which the controls are added to their container, or I should say they are rendered on their container. Here's an example that shows how z-order can change the static layout of objects on a form. In this case, as you see, there are 3 buttons in this form: button 1, button 2, button 3, and the z-order of button 1 is 2, the z-order of button 2 is 1, z-order of button 3 is 0, and the one with z-order 2 is rendered first, is drawn first. That's why it is on the bottom of the stack, and it can be viewed only partially because some part of it is masked by button 2 with the lower z-order. Z-order 1 button, which is button 2, is on top of button 1, but it's at the below button 3, and some part of button 2 is masked by button 3. Button 3 has not been masked or is not masked by any other button because it has z-order 0, so it is drawn or rendered at the very end. The easiest way to change the z-order is that at the design time you can right click on a control and choose the bring to front item that will bring the control to z-order 0, or you can choose the send to back item. The send to back item is going to set the z-order to the last item in the collection. And during the runtime, you can use the control the bring to front or control the send to back method to do the same operation in a dynamic fashion in the runtime. Also, you can basically go to the document outline in Visual Studio 2022 by navigating to View, Other Windows, and Document Outline. When you do that, you will see a window like this, and it allows you to move different objects up and down to change their z-order. You can try it. This is very simple in Visual Studio. Now let's talk about tab order, which is different from z-order. Just as you can control the visual order of your controls using the z-order, you can also control the sequence in which a user can navigate through them during runtime using the key tab. This sequence is known as the tab order. Basically, a control can be registered to be included in the tab order when you set its Boolean tab stop property available in the list of properties of that object to true. You need to just go to the property tab stop and set it to true. The default is also true. If you don't want the object to be included in the tab order sequence, you can just set it to false. The position of a control in the tab order is determined by its tab index property. There will be a tab index property where you can set the property to 0, 1, 2, 3, 4, so on and so forth. It's a non-negative integer. The integer value that the Windows Forms designer automatically generates for the controls can be manipulated and basically you can give it like different orders. The index starts from 0, that would be the first control that can be accessed using tab, and then after that it increases for each subsequently dropped control on the form. Not only you can change the tab index integer in the properties window and give it whatever value you want to change the tab order of objects in a given container, like a form that you see here in this picture. You can also visually set the tab order using the Windows Form Designer by clicking on the View Tab Order. So go to View, select Tab Order, and then this view will pop up, and then you can very conveniently change the tab order based on whatever you decide the order should be, and you don't need to write any code for this. Now let's talk about dynamic layout and how to customize dynamic layout. Now you may say, all right, so far we are able to change the position, the size, the Z order, the tab order, and other properties like margin and padding of an object. What else do we need to know? Well, everything looks fine if the user doesn't resize your form, but when the user resizes the form, then the objects may not look nice, or the position, the alignment, the margins, everything can be completely out of shape if the user resizes your form. For example, as you see, this form is originally has a certain width and certain height. If the user decides to elongate the form's width and make the form width longer, then the question is how the control objects that are included in this form will look like. Are they in a nice alignment or not? To answer these type of question and to make sure that dynamic alignment or dynamic layout is as nice as its static alignment or aesthetic layout, we are going to consider a few properties and study the dynamic layout separately. The first property that you have to consider changing when you want to set up the dynamic layout of a program is anchoring. What does it mean? Preserving the distance between the edge of a control and the adjacent edge of a control's container is called anchoring. By default, all the controls are anchored to the top left edges of their container. You can try it. The buttons, the text boxes, so on and so forth. We are accustomed to Windows moving the child controls to keep their anchoring intact as the container's left or top edge changes. But we haven't seen the moving of child controls when the other edges, the right edge or the bottom edge of a containing form changes. Now, how do we do this? We can change the anchor. I'll show you how anchoring can change, but remember that Windows doesn't resize controls automatically to anchor them to the edges on the right or edges on the bottom. It only does it. It only moves the inner controls in a way that their distance with respect to the left or the top edge are preserved. When you want to modify the default anchoring of an object, you can again go to the properties window of the Visual Designer in Visual Studio and basically navigate through the properties and find out the anchor. And then, as you see, the default is top left, but you can click on, let's say, this rectangular button, or this rectangular button if you want to include other anchoring, like right anchoring or bottom anchoring. Remember, the anchor would be an object of anchor style, which is a numerator, which can get any combination of top, bottom, left, and right. As you see, top, bottom, left, and right are constants: 1, 2, 4, 8. These are powers of 2. So when you pick multiple edges like the top, bottom, left, and right, then the value anchor would be the sum or the bitwise order of these values. If you want to select them all, then the anchor style or the anchor value will be top or bottom or left or right, which is equal to 15, which is basically the sum of all these numbers: 1 plus 2 plus 4 plus 8. Here is an example of how dynamic behavior of your forms change when you're setting the anchor to a value other than the default value. In this case, the anchor property of the text box is set to top, left, right, and then if you resize the containing form from this shape to this shape, so basically you widen the form, then as you see, this distance between the right edge of the text box and the right edge of the form will not change even after making the form wider by, let's say, grabbing this border and dragging it to the right and then dropping it. So as you see, that's a very nice property that you can change to assure that your form and its containing objects will remain in a nice alignment and nice shape in the dynamic under the dynamic changes to the size and shape of the containing form. Let's assume that you have 9 buttons that are sitting inside a form. This is the initial position, and let's say you have set the anchor of every button to its text, to its label. This one is top left, this one is left, this one is bottom left, bottom right, right, top right, and this one is top, bottom, left, and right. In this situation, when you expand the size of the containing form, when you increase the size of the containing form, what's going to happen? As you see, the middle one, which is anchored to top, bottom, left, and right, will increase its size automatically, while the others preserve their sizes. The only thing that changes in the other is their locations, right? Maybe I should say not the location of this one, but let's say the location of this one will change. It gets further from the left neighbor and the bottom neighbor. Why? Because it wants to keep its distance from the right or the top edge of the border, because it is anchored to the top right. Now, this is the previous example. As I showed you, we had 9 buttons. In this example, we are shrinking the size of the containing form too much, and that causes the buttons to violate each other's margins, and basically buttons masking other buttons or the neighboring buttons because they want to keep the anchoring the way you have decided to be, but they cannot avoid violating each other's margin, because we have simply decided to shrink the size of the containing form too much. In order to fix that, we can use the minimum size property and basically set the minimum size property so that the user cannot shrink the size of a form more than some threshold. Another property that helps us customize the dynamic layout of objects is called docking. Docking is a way to identify the edge that you want a control to stick itself to. For example, sometimes I want my menu strip to be docked to the top edge. By default, the menu strip is docked to the top edge. But some other objects, let's say a button, a text box, is not by default docked to any edge of the containing control form. In these situations, you can adjust the docking if you want by just navigating to the corresponding property and change the docking to one of these dock styles, either none, which is the default, or top, bottom, left, right, and fill. You cannot choose a combination of these. That's not like anchoring. You cannot dock to both top and left. That doesn't really make sense, because docking basically means how to whether or not to stick to one of the borders. It doesn't mean to like keep the distance. That's completely different. And you can see the different examples of docking. When you set the dock style to top, then this will happen. This is an example. Then when you set it to button, then this is gonna happen. For example, all the status strips are by default docked to the bottom edge of the containing form, and then you can set the dock to docking style.Fill, and this will happen. Basically, your control object is going to completely fill the containing object. That's very useful for filling an image to the whole form, or filling a panel to the whole form. That's very useful. You'll see examples of this in the future. It is possible to dock multiple control objects to the same edge, right? For example, let's say you have two status strips on a form, and they both by default are docked to the bottom of the edge. They're sticking to the bottom of the bottom edge of the containing form. In this situation, Z order would be decisive. The Z order of the docked controls determines the order they stick to an edge. So remember, if you don't like the current order, you can change the Z order of the objects that are docked to the same edge of the containing control, or to the docked to the containing form, I should say. In order to set the dock style, you can either use the dock property and change the dock property yourself, or you can use some smart tags. Here's an example of changing the docking of, or the dock style of the panel object to fill, right? You can either change the docking by going to the properties and find the dock property and change it there, or you can just click on this smart tag, and when you do this, this panel will fill this whole containing form, and this becomes this shape becomes this shape. You can undock it by clicking on the link that shows up in the same smart tag. So I just wanted to show you this nice feature of Visual Studio. A control object that can help you a lot to adjust the dynamic layout of objects in a form is called toolstrip container. I recommend that you use it for lots of applications that you're going to make, because it has a very powerful behavior or set of behaviors that allows you to manage the dynamic layout of the objects sitting on it. The toolstrip container basically looks like this. You can set the DockStyle.Fill. That's the best option. Let's say you use the smart tag to do so, or you just use a dock property to set the docking to DockStyle.Fill. And after you fill your whole form with the toolstrip container, then you can enjoy the 4 sub panels or the sub containers that is given to you. We have top toolstrip panel, this one. By clicking on this, you can make the left toolstrip panel visible as well. You can also make the bottom toolstrip panel visible by clicking on this, and you can make the right toolstrip panel visible by clicking on this. And after you make them visible, you can basically use them to host some other menu strips or some other objects, and basically you can enjoy the layout that is provided to you by the toolstrip container. Another container that you can add to your form to basically manage and handle the dynamic layout of your form in a nice fashion is called the split container. A split container splits the containing panel to 2 separate panels. Either it splits them vertically or horizontally. In order to dynamically move the border of the 2 subpanels and allow the user to basically grab the border between the 2 subpanels and move it to the left and right for vertical splits, or move the border up and down for the horizontal splits, you can basically use a splitter which is added vertically to a subpanel with the DockStyle left or right, or it can be added horizontally to a subpanel with the DockStyle top or bottom, and this way the splitter can let the user dynamically move the border between the 2 subpanels. Sometimes the user wants one subpanel to be bigger than the normal or smaller than normal, so they can do that by just grabbing the splitter and move it sideways, or you move it up and down in the case of horizontal splits in a split container. Finally, please note that if you want your dynamic layout to be managed in a way that you always keep a grid shape panel, you can use the table layout panel. If you think of a calculator program that has to display the text box or the display showing the numbers, and it has to display all the buttons for basically digits and operators like plus, minus, star, slash, and other buttons. The best layout, the best dynamic layout for that calculator program would be a table layout panel. Basically, you can specify the number of rows and columns of your table. After you add the table layout panel on your form, you can set its docking to all, and basically you can change its number of rows and columns using Visual Studio, you can change the width of each row or each column, either by specifying a percentage or some absolute value in terms of pixels. In this small example, as you see, there are 3 columns in the table layout panel, and each of them will have a width equal to 33.33% of the total width of the table. That means we are equally dividing the width of the table into 3 separate columns. You can change these percentages, or you can replace the percentages by absolute values. So it's a very versatile dynamic layout that allows you to always keep a grid shape panel no matter how the user changes the containing forms, size, and location. Also, please note that you can add the different types of control objects like buttons, text boxes, and so on and so forth on different cells of your table. By default, each control object resides on one cell. If you want, let's say, your button or your text box to reside on multiple cells, you can change their column span or row span properties by setting them to integers greater than 1. For example, let's say you want to have a text box that sits on 3 consecutive rows, or let's say 3 consecutive columns on a table layout panel. All you need to do is to set the column span or row span to integer 3, and that's it.